submitted. I think they can make their corrections and resubmit. Okay. Then, sorry. Yeah. So I was discussing about the properties of PN sequence, right? Yes, sir. No?
Yes, sir.
Yeah. Is it possible any one of you to say what are the properties of pseudo-noise sequence? Yeah. Yes, quickly, any one of you. Already one property I am displaying. At least other two properties, at least first name and then what it is very simple. Properties of a PN sequence or M sequence, what I can say. Then it shows if you are not opening up your mouth.
We did 3 properties.
Yeah.
Balance property, run property, and autocorrelation property.
Okay. So what is balance property?
Like in each period of max length sequence, the number of ones are equal to 1 more than number of zeros. Like number of ones will be 2 power m minus 1 and number of zeros will be 2 power m minus 1 minus 1.
Very good, man. Very good. So exactly
And
what you said is correct. Okay. So in a given PN sequence, right? So the number of ones will always be one more than the number of zeros. Okay. So that is the balance property we say. Yeah. Similar to that, anybody else can say what is the next property? It is quite interesting also, and yeah, second property. Yes, other students. Yes, be fast. Other students should open up their mouth and say what is the second property I discussed. Yes, if nobody is opening up their mouth, then I have to start calling names. Hello.
Run property, sir.
Yeah, what is that, man? What is that run property? How do we define a run? How do we define run?
Sir, in this property, among the runs of ones and zeros, each
Okay.
period is having maximum length sequence. Like 100 runs of each kind of length 1, 1/4 of length 2, 1/8 of length 3, and so.
Yeah, I displayed here. I said we define run as what? A series of ones and zeros grouped consecutively. Right? I repeat once again, a series of ones and zeros grouped consecutively, we call that as a run. Right? So, for example, with this, see, 2 zeros are there continuously, right? So we group that and we call that as one run. The next 3 ones are there consecutively, we group that as another run. Then only single bit 0 is there, so that is another run. Then single bit 1 is there, so that is another run. So totally I can say this particular sequence has 4 runs. Okay, and what is that rule is half of the sequence, right? That is one half the runs of each kind will be having a length of 1, right? Then 1/4 are having a length of 2. Then 1/8 are having a length of 3, and so on, as long as these fractions represent the meaningful numbers of runs. So that is what is done this. So out of 4 runs, okay, so 2 runs are having a length of 1, that is 0, single 0 and single 1, right? Then 1 run is having a length of 2, that is 2 zeros here with this example. right? Then one run is having a length of 3, that is 3 ones. So this is about the run property. Then I think I discussed about autocorrelation property. What I said in autocorrelation property is the autocorrelation function of a maximum length sequence is periodic and binary valued. Okay, the autocorrelation function of a maximum length sequence is periodic and binary valued. So here, if the period of an M sequence is L, then which is equal to what? L is equal to 2 power M minus 1, where I said M is number of shift registers. Then the autocorrelation function of this M sequence is periodic in nature and it assumes two values. What are those two values? One is L and another one is minus 1. Okay, so that I told yesterday with example also, right? Yes or no? Yeah. So this is what I discussed yesterday. So I can say what is the autocorrelation function? How do I define? So the autocorrelation function is defined in terms of these bipolar sequences, that is C suffix n, right? As what? So RC of M, that is what the autocorrelation function, right? Which is equal to summation n is equal to 1 to L Cn into Cn plus M. Okay, so here the value of M can vary from 0 to L minus 1. Okay, so what is that L? L is the period of the sequence. L is the period of the M sequence, and that sequence Cn is periodic with period L with the autocorrelation sequence RC of M is also periodic with period L, I said. Right, so for that I have taken an example. And I said, how do we say that it is having two values, right? Yeah. Okay, of course, still here I'm dealing with the mathematics. So what I said, the ideal autocorrelation sequence is for Cn is RC of 0, which is equal to L. Means when M is equal to 0, the value of that autocorrelation sequence will be is equal to the length of the Pn sequence, right? And RC of M is equal to 0. That is when the value of M lies in this range, less than L minus 1 and greater than 1. So the M sequences, the autocorrelation sequence is what? We say RC of M is equal to L when M equal to 0 and it is minus 1 when the value of M is less than or equal to L minus 1 and greater than or equal to 1. So this is how we have proved yesterday. Okay. And for long M sequences, the size of the half peak values of RC of M relative to the peak value RC of 0 is this. RC of M divided by RC of 0 is equal to, we say, minus 1 by L, right? Because RC of 0 is what? Is equal to L, and RC of M is equal to minus 1. That is why we say it is equal to minus 1 by L. Right, so therefore I said M sequences are very close to ideal PN sequences when viewed in terms of their autocorrelation function. So this is all with mathematics, I said. So here I took an example. Okay, how I take that PN sequence. I have taken 00, 111, 01, whatever I consider earlier, the same sequence I have taken. So the length of the sequence is 7 bits, right? So that is why I write C7, right? Because the value of n is 7. So C1 is the first bit, C2 is the second bit, C3 is the third bit, C4, C5, C6, C7, like that, right? So how do I write that RC of M is equal to summation n is equal to 1 to L Cn into Cn plus M is the expression for that, right? So now I said RC of M will be equal to what? L when M equal to 0 and it is minus 1 for the value of M when it is less than or equal to L minus 1 and greater than 1. So we need to find out that, right? Here, looking at the sequence, what I can say means I should get, when M is 0, that is RC of 0, I should get 7. Okay. And for any other value of M, Okay, that is less than 7 and greater than 1, I should get its value as -1. So that is what the meaning of this equation 2, right? So that I am going to prove here. So I first named what is the C1, C2, C3 among this, right? So first bit I said it is C1, then C2, C3, C4, C5, C6, C7, right? So here uh, 3 bits, that is C1, C2 and C6 are 0, right? So I represent 0 by -1, and the rest of the bits, that is C3, C4, C5 and C7 are 1. Okay, so how do I get the value of RC of 0? So I am going to expand this equation, okay, by substituting m equal to 0, right? So RC of 0 is equal to, so you vary the value of n from 1 to l, okay? So when n is 1, okay, and m is 0, what I can write here? First this one is what? C1 into C1, right? So that is why it is written C1 into C1. Yes, hope you are understanding what I am saying. In this equation, I am substituting the value of m as 0 and I am varying the value of n from 1 to L. So here what is the value of L? L is 7, right? So the first is what? When n is 1 and m is 0, I get C1 into C1. Next is, anyway m is 0 only, right? Next second value is what? N is 2. So when n is 2, I get the second term as C2 into C2. Similarly, the third term is C3 into C3, fourth term is C4 into C4, fifth is C5 into C5, sixth is C6 into C6, then seventh is C7 into C7. So already I said what is the value of C1 to C7. So just I am substituting that, I am finding it what it is. So I said C1 is -1, so that is why it is -1 into -1, it becomes +1. Right? Then C2 is also -1, that is why it is -1 into -1, it becomes +1. Then C3 is +1, so +1 into +1, it will be +1, so +1 is written. C4 is also +1, so +1 into +1 is +1. Then C5 is also 1, so I can write +1 into +1 as +1. Then C6 is -1, so -1 into -1, it becomes +1. Then C7 is 1, so +1 into +1, it is +1, right? So if I sum up this, I will get 7. Yes, that is why I say RC of 0 is equal to 7. So which is holding this equation. When m is 0, I am getting the value of this autocorrelation function as the length of the sequence, L, right? So now let me try to understand for other value of m, whether I am getting it as -1 or not. Okay, so I have taken here the value of m as 3. Okay, so when I take m as 3, so I need to again expand this summation, right? So when RC of 3, okay, now the value of m is 3, right? So start from again 1 to 7. So when I substitute n as 1, what I get? C1, here n is 1, so the value of m is 3. So 1 plus 3 is 4. So that is why I written C1 into C4. Next is what? When n is 2, so C2 into what? So n is 2, no? So 2 plus 3 is 5. So C2 into C5. Next is when n is 3, right? So I get C3 into C6 because n is 3 and m is 3. C3 into C6. Next, when n is 4, I get C4 into 4 plus 3 is 7. So C4 into C7. Next is when n is 5, so C5. So 5 plus 3 is 8. 8 means again it comes back to 1, right? So that is why I written C1. Okay, here the length is 7, right? So that is why instead of in place of C8, I am writing it as C1. Then next, when n is 6, I can write C6 into, so 6 plus 2 is 6 plus 3, right? M is 3. So 6 plus 3 is 9. So C9 is nothing but C2. So that is why it is written C6 into C2. Next, when n is 3, when n is 7, so C7 into 7 plus 3 is 10. So C10 is nothing but, yes, what? 8, 9, 10. It is C3, right? So C7 into C3. So now you substitute the value of the C1, C4. So C1 is -1 and C4 is +1. So -1 into +1 is -1. Then C2 into C5. C2 is -1 and C5 is +1. So -1 into +1, again it is -1. Then next is C3 into C6. So C3 is plus 1 and C6 is minus 1. So plus 1 into minus 1, it is minus 1. Then C4, C7. So C4 is plus 1 and C7 is also plus 1. So plus 1 into plus 1, it is plus 1. Then C5, C1. So C5 is plus 1, C1 is minus 1. So plus 1 into minus 1 is minus 1. Then C6, C2. So C6 is minus 1, C2 is also minus 1. So minus 1 into minus 1, it becomes plus 1. Then C7, C3. So C7 is 1 and C3 is also 1. So plus 1 into plus 1 is plus 1. So if I add that, how many minus 1, minus 1, minus 1 is minus 3. Minus 3 plus 1 is minus 2. Then minus 2 minus 1 is minus 3. So minus 3 plus 2 is minus 1. So I'm getting RC of 3 is minus 1. So which is holding with this value. Similarly, you can try for any other value of m. You can try for m equal to 4 or m equal to 5 or m equal to 6 and check whether you are getting that value is equal to minus 1 or not. Okay. So hope you will be able to do that. Yes, will you be able to do that and tell me the answer Monday? Monday I have next class, right? Yes, my dear students, all of you are note down this. Check for other values of m and find whether it is equal to minus 1 or not. Okay?
Yes, sir.
Yeah. Okay, so I think rather than understand, I think this is simple to understand. Hope I have conveyed what is this autocorrelation function of PN sequence. Then the same thing has been told with waveforms. Okay, so here I have taken the sequence as what 00, 111, 01, same sequence only, but it has been repeated 2 times. Okay. Right, as I said, it is a periodic sequence, right? So it repeats for every 7 bits with respect to this example. And I said every bit duration is known as TC. Okay, that is the chip duration, what we say, right? So n into TC, here n, the value of n is 7. So 7 into that much you will get. So already I calculated what is the value of RC of m, right? So when m is 0, right? When m is 0, what is the value of that? It is 7. So that is why I have shown with the value of L. Okay, when m is 0. And for other values, that is when m is equal to 1, 2, 3, 4, 5, 6, 7, I am getting the value of minus 1, right? So that is why it is shown with minus 1. Hope this point is clear. Why I have shown when m is equal to 0 as L and for other values of m as minus 1. So that has been repeated. Okay. Yes. And don't compare directly with the duration of this one because slightly it is less than that, right? Hello? Is this point is clear? I'm asking. And this repeats for every, and it is periodic also. Okay. Yes, hope you got this point. What is the autocorrelation function of PL sequence?
Yes, sir.
Yeah, it has only 2 values. One is L and one is minus 1. So here the value of L is 7. And another part I said, don't compare directly with respect to this sequence because it is slightly written less than that. Okay. Yeah. So the next one is about the gold sequence. Gold sequence. Then we discuss about the Kasami sequence. 2 things are there. Of course, we don't go so depth like how we have discussed about the PN sequence. So just you need to understand. Means if you understand PN sequence, then I think you will be able to get an idea about the PN, this gold sequence. Okay. Yeah. So what it is, 2 people in the year 1967 and 1966. Okay, that is they are known as Gold and Kasami. Say their name or that. That is why their name only has kept for their invention. Okay, Gold and Kasami have developed methods for generating the PN sequences with better periodic cross correlation properties. Okay, so the two sequences, when compared bit by bit, should show minimum similarity. Okay, uh, that is what is the cross correlation property than the M sequences. Okay, so the gold sequences are constructed from pair of preferred M sequences. Okay, preferred M sequences. Okay, so gold sequences, as I said, are constructed from pair of preferred M sequences. That is, any two PN sequences which generate gold sequences with a good cross correlation. Okay, by modulo 2 addition of two maximal sequences. CM sequence or PN sequence are same, right? Of the same length. This is how we call as gold sequence. I repeat once again, the gold sequences are constructed from the pair of preferred M sequences by modulo 2 addition of two PN sequences of the same length. Okay, that is known as the gold sequence. So to say what are the preferred M sequences, in that way we say any two PN sequences which generate gold sequences with good cross correlation that we select. So with a set of two preferred PN sequences of length L is equal to 2 power m minus 1, we can generate 2 power m plus 1 different gold sequences by modulo 2 addition of the first sequence with each phase of the second PN sequence obtained by the cyclic shift. Okay, so here what you need to do is you need to assume two PN sequences of the same length. Okay, two PN sequences of the same length. How do we select the two PN sequences of the same length? So which are having the good cross correlation. Such sequences only we select, not all sequences. And by doing modulo 2 operation of that, so we will be able to generate a gold sequence of what length? 2 power m plus 1. So as an example is shown here, which is having a length of L equal to what? Is it possible to say, looking at this diagram, what would be the length of each PN sequence? Yes, my dear students, is it possible to say? See, you all know this is one PN sequence, right? This is how the PN sequence generation looks like, no? Circuit. And this is another PN sequence. So both the PN sequences are having the same length. So we are doing the modulo 2 operation of those two sequences to get the gold sequence. It is very simple to understand. But looking at this diagram, is it possible to say what is the length of each PN sequence here? Of course, we have used, I said, same sequence length should be.
Sir,
Yes?
is it 31?
31 bits, 2 power
Yes.
5 minus 1.
Yeah, 2 power 5 minus 1. Because looking at this, see here 1, 2, 3, 4, 5 indicates the flip registers, right? Flip flops. So that is the number of shift registers. So it is 5. So as I said, the PN sequence length will be 2 power 5 minus 1. So 2 power 5 is 32. So 32 minus 1 is 31. So we have two PN sequences having a length of 31. Right. So we do the modulo 2 operation of those two sequences to get the gold sequence. Okay. So that is what is written here. So generation of gold sequences of length 31 bits. Means after doing this modulo 2 operation, we get a gold sequence and its length will be equal to what? 31 bits. Is that fine? So with a 5-bit shift register, we can generate, I said, 6 different PN sequences, each having a length of 31 bits, using 6 different polynomials. Okay, and we can have 15 sets. That is why it's written 6C2. Okay, of the PN sequences that can be used for generating this gold sequence. So this is a combination 6C2. So is it possible to say any one of you what is the formula, what we can write? Hope you remember this NCR, then NPR. Anybody remember? Yes. What I said is you could get that point. No. Okay, so at least be prepared to try to catch this point. So 31-bit gold sequence. At least you should visualize 5 shift registers to get a one PN sequence, like that 2 PN sequences, right? Of course, the generation of this PN sequence and this PN sequence will be of a different kind. I think you may be understanding looking at the feedback where it is taken and model 2 operation is done. But finally, the output of these 2 PN sequences will be modulo 2 operation is done to get the gold sequence. Yeah. So with the 2 preferred means what I wanted to say is with this 5-bit shift registers, as I said, we can generate 6 different PN sequences. Okay, each having a length of 31 bits. 6 different polynomials. Okay, so we can have 15 sets of PN sequences that can be used for generating the gold sequences. Yeah, so with the 2 preferred PN sequences, one we say it is X of K, another one we let us say it is Y of K, having a length of 31 bits. We can generate 31 gold sequences by modulo 2 addition of X of K with each of what? Y of K plus 1, Y of K plus 2, and so on up to Y of K plus 30. Okay, so X of K is one PN sequence and Y of K is another PN sequence. So these are the 2 preferred sequences having a length of 31 bits. How do we generate the 31-bit gold sequence? I said by modulo 2 addition of X of K with each of what? Y of K, then Y of K plus 1, Y of K plus 2, and so on up to Y of K plus 30. So this Y of K plus 1 represents the sequence Y of K with the cyclic shift of 1 bit. Similarly, Y of K plus 2 represents a sequence Y of K with cyclic shift of 2 bits, and so on. So in addition to this 31 resulting gold sequences, so this X of K and Y of K alone can also be used as gold sequences. So totaling with 31 I said, right? 31 plus these 2. So it becomes 33. So hence it is written as 2 power m plus 1. So 2 power 5 is 32, right? 32 plus 1 is 33. That is why in the previous slide it is written here. We can generate 2 power m plus 1 different gold sequences by modulo 2 addition of the first sequence with each of the second PN sequence obtained by cyclic shift. Hope I am conveying what I wanted to convey. So with the 2 PN sequences having a length of 31 bits, right, we will be able to generate a gold sequence having a length of 31 bit. Right. In addition to that, we will be able to have 2 more gold sequence along with what? X of K and Y of K alone. So with that, we say totally 33 gold sequences we can generate. Okay, here 2 sequence, one is X of K, another Y of K. I said what? X of K is added with the cyclic shift of Y of K. Okay, so and all these gold sequences have the high cross correlation. Okay, so that is why they are preferred in spread spectrum. Okay, so this is a little bit about when m is odd, what happens? When m is even, what happens? Okay, so for m is odd, we say the maximum value of the cross correlation function between any pair of gold sequences is given as root of 2 into L. That is, we denote this maximum value of cross correlation between any pair of gold sequence as what? R suffix max, which is equal to root of 2L. And for M is even, the value of R max is equal to root of L. Okay. In the same way, to say about the Kasami sequence. So, Kasami described the method for constructing the PN sequence by decimating an M sequence. So, hope are you aware of this? The meaning of decimation? Anybody can say what is decimation? Any one of you? You might have heard this word decimation in some other places. Decimation, at least I think in up conversion and down conversion. Hope you will be able to recall. Yes? Able to recall or not? No idea. ಯಾರು ಏನು ಮಾತಾಡ್ತಾ ಇಲ್ಲ ಮತ್ತೆ ಸಾಟರ್ಡೆ ಅಂತನಾ ಏನು Yes, my dear students.
Sir, is it eliminate?
ಗೊತ್ತಾಗ್ಲಿಲ್ಲ.
Elimination.
Elimination. Decimation means elimination. Elimination. Okay. Then anybody? What about Vishal? Why Vishal has become very silent? What mean Vishal? I think he's not there.
Sir, I think decimation means sampling it by a factor of 10.
Yeah, 110. 1 by 10 means it's 0.1.
Yes, sir. Decimal 110.
Yeah, that is true, what you said. Okay, usually I thought you might have come across this decimation in downsampling and upsampling. I don't know. Okay, fine. Anyhow, so by decimating an M sequence, we will be able to generate the Kasami sequence, he said, right? So how do we select that? So for every 2 power m by 2 plus 1 bit of an M sequence is selected, okay? That yields a smaller set of PN sequence compared with the gold sequence, but their maximum cross correlation value will be root of L. Okay, here in case of gold sequence, the value of the maximum cross correlation depends on whether the value of M is odd or even, right? So when it is even, it is root of L. When it is odd, it was root of 2L. But here with the decimation, is able to get the maximum cross correlation value of what? Only root of L. Yeah. So a set of n sequences of period L with a lower bound on their maximum cross correlation is given as R max will be greater than or equal to root of n minus 1 divided by n into L into minus 1. Okay. So for large value of L and N is well approximated as what we can say R max is greater than or equal to root of L. When the value of N and L is large, then it will be approximated to what? It is only root L. Okay, hence we say Kasami sequences satisfies the lower bound and they are optimal. So it is better than gold sequences. But gold sequences with M odd also have a value of what? Maximum cross correlation is root of 2L, right? So hence we say they are slightly suboptimal. So gold sequences are suboptimal and Kasami sequences are optimal codes as far as their cross correlation is concerned. So the cross correlation has to be maximum, then we will be able to achieve the better coding. Okay, so this is all about the sequences which are used in the split spectrum. As I said, gold sequence and Kasami sequence we are discussing on just lighter side. Okay, at least you should be thorough with this PN sequence and its properties. Is that fine? Hope you will be able to take up any given problem on PN sequence, at least in verifying the properties, balance property, run property, and autocorrelation property. Okay. Definitely, there will be one question on that. Yes, if you have any doubts, you can ask. Otherwise, I can move on to the next topic. Yes, my dear students. So before I think move on to the next topic, let me have a discussion. Otherwise, you will be like silent. So at least let me ask some of the people. I think everybody can work out this. Taking some people can do for when the value of m is 4, and some people can do for when the value of m is 2, like that. For other values of m, can check whether you're getting its value as -1 or not. Okay, except 3. 1, 2, 4, 6, 7. Is it possible to do that? I will give 5 minutes time. I think 5 minutes is more than enough, no? To just check with this. Yes?
Yes, sir.
Yeah. So at least you have to make among yourself only for what value of m you are doing, and you should be able to present it. Whoever is presenting, they will be getting some reward. What to do? I have to show some chocolate only to get better response. I hope you are understanding. No reward in the form of what? Yes, I think everybody became busy in doing this. Is that so? So you want me to present that?
Yes, sir.
Oh, sorry. Oh, sorry, again I... Yeah. Is that fine now? Yes, is this fine?
Yes, sir.
Yes, Nareen is not there. Noreen?
Yes, sir, I'm here.
Yeah. Yeah, I wanted to... I think I have returned no, your assignment.
Yes, I have to
Yeah,
just add
yesterday.
more,
Yeah,
do
yesterday
it.
what I said while you asked, no, is that what you have done is correct.
Yeah,
Yeah,
I have to
after...
just add, do the iterations a few more times. That's all.
Yeah. Hope you not misunderstood, no? Whatever I said.
No, I understood, sir.
Yeah. Yes. And even other people who have submitted, I think I think everybody, whoever has done mistake, no, same mistake others also have done. It is copied, I feel, whoever has submitted. Some people have submitted. Where is Manoj? Manoj is there. Manoj. Ila. Manoj is there. Manoj.
Yes, sir.
ಎಲ್ಲ ಇನ್ಕಂಪ್ಲೀಟ್ ಮಾಡಿದೆಯಲ್ಲ, ಚೆನ್ನಾಗಿ ಮಾಡಿದೆಯಾ ನೀನು, ಬಟ್ ಯು ಆರ್ ನಾಟ್ ಕಂಪ್ಲೀಟೆಡ್ ಫುಲ್ಲಿ.
Yes, sir. I will do it, sir.
You are
I will
not
submit it by today evening.
You have not calculated what is the maximum length of the sequence you are going to get. You have stopped, I think, around very near to that value. 12 steps means after one you thought that it will not continue. Is it so?
No, sir. No, sir.
Then Gautam Hegde also submitted, but is also incomplete.
Yes, sir.
ಆಮೇಲೆ while uploading, you have to upload it properly, man. So I will not be able to rotate. Only I can zoom in and zoom out. Then I think Chandana is
Okay,
there. Yeah, Chandana is there, no?
Yes, sir.
Yeah, hope you understood what is the mistake.
Yes, sir. I have also submitted again.
Again you submitted. Good. Okay, your presentation is good, but only thing is you have gone wrong at some step, right? So here the problem is if you do any one step mistake, no, so entire sequence will go wrong. And yes, next I think Manasa also submitted. Manasa RA, right? Am I correct? Manasa RA or Manasa SH? Manasa RA, I feel. Is it so? Manasa RA?
Sir? Yes, sir.
ಎಲ್ಲಿದ್ದೀರಿ ಎಲ್ಲ ಏನೋ ಮಾಡ್ತಾ ಇರೋ ತರಕಾರಿ ವ್ಯಾಪಾರ ಮಾಡ್ತಿದ್ದೀರಾ ಹೆಂಗೆ?
No, sir.
ನೀವು ಹೇಳೋ ಸ್ಪೀಡ್ ಹಂಗೆ ಅನಿಸ್ತಾ ಇದೆ. You have submitted that PN sequence assignment, right?
Yes, sir. I have resubmitted.
You understood where the mistake you have gone?
Yes, sir. In the step 2, sir.
Yeah. Then Pooja you have done, right? Yes, Pooja. Hello, Pooja. Matila. There is a mistake, sir. Okay, ma. ಯಾಕೆ ಮಾತಾಡ್ತಾ ಇಲ್ವಲ್ಲ ನೀವು? ಶ್ರೇಯಸ್ ಆಲ್ಸೋ. ಶ್ರೇಯಸ್ ನೀನು ಅಲ್ವೇನೋ ಮಾಡಿದ್ಯಾ, ಬಟ್ ಮಿಸ್ಟೇಕ್. ಮಾಡಿ. What about others? What about Sneha? Then
I'll submit, sir.
ಮಾಡ್ಬೇಕು. ಇದೆಲ್ಲ ಸಿಂಪಲ್. This module is very easy. Module 5 is one of the most easiest and a few number of topics only there. So if you learn it properly, definitely you will be able to score good marks. Okay, so